All right. I'm Sean Fisk from Mission Design and Automation. Today we're going to talk about simulations and kind of the effects and benefits that go along with that kind of design and conceptual phase that goes with that. On the screen, you should see our slideshow real quick of our simulation setup. Primarily what we're looking to see on these kinds of things are statistical collection of information, as well as, kind of proof of concepts and things that go along with kind of designing and conceiving machines from start to finish and everything that goes along with that. So long story short, let's jump into the next slide real quick. One of the things that I'd like to go over is just kind of the overview of what simulations are as a whole, and an effective way to provide, collecting information and testing designs and concepts, like you see on the screen, it's, shows capability as well as figuring out what your process and the most effective way of showing your process, finding your bottlenecks, your ergonomic improvements, how tall is it? Can people get at it easy? Is your maintenance staff going to be real happy about being able to get to those sensors, that cable, that cat track, whatever, We also want to know how big the machine is going to be as a whole. Floor space is at a premium nowadays. No one likes to see big machines. Nothing like that is much fun. And so it'd be nice to be able to jump ahead of the ball before the machine is built, find out all those little snags that, a robot needs extra reach, et cetera, and find all that information out as effectively as we can. Also, like it says right there, optimization and scheduling. So we can find out how much material we're using, figure out what we're going to need throughout the day, best ways for it to come in, et cetera, and generally find out the entirety of the time that's required to effectively use your machine and factory level things. Next slide, please. So there are traditionally two types of simulation that you generally deal with automation equipment. One is your traditional simulation. This goes everything from process flow to plant layouts, and just generally a useful tool to find out where most of your areas of improvement could be, as well as how you would like to see the design of the machine, and figuring out what materials and usage you're going to use. It's the fastest and the most effective way of doing simulations, and it's a quick and easy response to do most things. The other type of simulation, go ahead, yep, is called a digital twin. A digital twin is an exact duplication of your machine design concept. It is everything from the pure mechanical aspect of it, from cylinders, sensors, switches, to hydraulics, to motors and actuators with specific timing, accel, decel, the whole 9 yards that goes along with it. So you're able to find your closest real time cycle time for your machine, your output, everything from top to bottom. It's a real design top to bottom in a digital space, which means that you don't actually have to build it. You don't actually have to put it in your floor. You don't actually have to put operators in it. You can do a digital compilation of everything together and see how effective it is as a whole. All right. So that being said, I'm going to go ahead and do one real world example of what an effective use of that is. And I'm going to go ahead and take over the screen here. All right, everybody still hear me fine? So you can see on your screen here, I've developed a sizable little plant floor here. And I've gone ahead and kind of populated it. It's even got a maintenance area. It's got a truck out in the bay. It's got a break area with some office supplies and a TV on the wall, of course, because what break room doesn't have a TV? Crazy people. Still working on that here. But so I've got some injection molding machines that I threw together real quick, and go ahead and hit play, and we're going to start seeing the guys start moving around, right? It's already making parts. Robots are going in. They're grabbing the whole 9 yards. Let's go ahead and speed it up. So now you're seeing we're pumping it out. You see a high-low booking around the corner. He's doing his thing. Operators are inspecting, placing everything in totes. Right now, so this is called a plant level simulation. And it's kind of going to give you some information that you're going to want to see, right? I can click on majority of these operators and actually find out a lot of useful information, such as, in this case, come on, catch up, Bessie. Such as the total move distance of my operator. I can actually tell you statistically how far, in this one, millimeters, I don't know why it's in millimeters, but this one has the ability to actually show you how far they traveled in a set amount of time. It's kind of crucial to know because who doesn't want to know that information? I don't want to walk miles every day. If I can move a container closer, et cetera, that's great. Great information to have. Next thing I would say is like, yeah, it's going to continue to build up and we're going to continue to do process flow. You can collect any information you want out of this thing. It can be cycle times. You can do, say, how long a robot has the part for, et cetera, you name it, it's there. But a real world example that I would like to show is the idea of, let's say, for instance, our lovely little press here has a capacity issue. We're going to say that suddenly this guy right here needs to be able to produce twice as much as it's capable. Well, I can't do that now, can I? I'm going to have to pick in a brand new press to kind of supplement that. But I want to find out what I can effectively do to do that, right? So things that I can, you know, what's our options? Our options are buy another press, buy another robot, buy another conveyor, right? Another option would be to, can I utilize the same robot and put a price right next to it and hop them back and forth? So, long story short, let's find out. Let's get rid of all this guarding. We don't need this, right? So, I'm going to duplicate this guy. Oh, now I've got 2 presses, right? Well, that's not good enough for me. I'm going to actually flip my panel over so I can actually get to it from the other side. So now my panel's on the opposite side. And now my robot should be able to try and grab that. Set out into the processing tab here. Do a quick guide right here. And you can see this is all my process flow. So all the direction for a specific part. So in my case, I'd like to be able to introduce this process flow real quick. Bam, there it is. Let's see if she works. Oh no, that's not good. Looks like my robot can't reach anymore. Says it right there. Position out of reach of the robot. It doesn't look like my robot can do that motion for all of it now. What's my solution for that? Well, 2 options, right? Move it real close. Maintenance becomes an issue. Clearances become an issue. Or figure out what robot actually makes sense and put that in place. So I'm going to go ahead and do that, actually. I'm going to grab a new robot. We love our FANUC. Since we've already got FANUC, we'll keep going FANUC. This being, what is that, an M10? Yes, M10, or M20, sorry. Let's upsize that to a, yeah, let's go at M710. That's a bit bigger, isn't it? Let's swap those robots around real quick. Select my robot. Apply. Bam, I've swapped robots now. Now I've got my 710 in there. Let's see if my robot can actually reach it this time around. Oh no. Not good. Let's find out what else is wrong. I think I know what it is. There we go. Long story short, now my robot can get in there. So now I found out that my robot may need to be swapped out. I found out that I can do it with one robot going back and forth if I would let it run long enough to do that. But it's just going to go back and forth, and that robot is perfectly fine doing that much utilization. And we can actually find out the utilization real quick by just throwing some information at it. Come on, buddy. Heading on in. Where are you? Statistics. Hi, buddy. And it's not up there. Great. All right. We have another option here. Where are you? Statistics. What up? There we go. And I can do a scenario of this. And it'll give me an actual percentage of the utilization of that robot. Crank up the speed. It'll be good to go. Let that run for a while. Oh, I love it. Or, well, we throw in some extra stuff. And I can see how many parts I've produced, 7 now. But you get the idea. The idea is you can generate a lot of things in there real quick and easily throw together some quick showing of information that you can do. You think about it, if you want to know that information, you can collect it and figure out your exact reaches of your robots and figure out what the best solution is without wasting time and energy and money on things that don't require it. So thanks a lot. Thanks for tuning in. Tomorrow we'll have bin picking with one of our lovely 3D vision systems. And thanks again.